let's talk about friction. So, most theories on friction forces are due to this guy, Charles Augustin de Coulomb, who is French, born in 1736 and died in 1806. Let us do a simple experiment. What you need is an eraser or your phone or just any object. Please place it on a table. Okay. And then let's apply a force P on that object. And we're gonna need to make some observations. The first one is for small values of P. If P is so small, too small, the box is not gonna move, or the block is gonna remain at rest, or whatever the object is. Your water bottle is gonna remain at rest. So for small values of P, well, P, the magnitude being of that force. So let me name that force P is P along EX. So for small values of the magnitude, the block will not move. The block remains at rest. And then we can keep increasing P until we reach some value where the object is gonna start to move. So we can keep increasing our applied force P until we reach some value when the block moves. And then when the block starts moving, we require some constant force P that is less than the force that is required for the box to move, to maintain constant motion. Let me say that again. So once the block is in motion, we still need to keep applying a force for the block to remain in constant motion, but that force that we apply when the block is in motion is less than the force necessary to initiate the motion. I will write this down. Okay, so once in motion, a constant value of P is required to move the block at a constant P speed. Usually this value of P is less than the value required to initiate the motion. And then let us repeat the same experiment, but add a force or a mass or something that's gonna increase the normal force between the block and the surface. So maybe just push the object down, apply a force downwards like this. That's gonna increase the normal force between the block and the ground. We're gonna see that in this case, the force is required to initiate the motion, and to keep the block moving at a constant speed is gonna increase. So when we increase the normal force, and the forces, the P needed, so when we increase the magnitude of the normal force, the P needed to initiate motion and to sustain motion at a constant speed increase. Okay. So these are just some observations about the quality of this friction force. Let me introduce the formal theory. So friction, according to Coulomb's model, has two types: static friction and kinetic friction. Okay. And static friction happens in a case like this. Say you have a block on an inclined plane, and the block is not in motion with respect to the inclined plane. So the relative motion between the two is equal to 0. Block sticking to the inclined plane. Okay, then the friction between the two is static. So in every case where the relative velocity is equal to 0 between the object and the underlying point on which it rests, okay, so when the relative velocity is 0 between the object and the underlying point at which it rests, then friction is static. Then friction is static. In this case, the friction force is an unknown. That we need to solve for. However, it should satisfy the static friction criteria. Which is that the magnitude of the friction force should be less than some coefficient we're gonna call mu s times the magnitude of the normal force. Mu s is called the static friction coefficient. Okay, we're gonna do some examples. Actually, let us do an example right now. So the example of the block on an inclined plane. What are the forces acting on the block? Well, we have the weight, the normal force, and the friction force. So the friction force is gonna be along the plane, the plane which is the contact between the box and the inclined plane, basically. I'm gonna talk more about the direction of the friction force in a bit. About kind of the direction, meaning in which plane it acts in a bit. Now, regarding the direction of whether the friction force is pointing up and down, actually I do not know if it's pointing up and down. The friction force is an unknown, and we will solve for the direction of the static friction force. Okay, so if this angle of inclination is alpha, and I can take EX and EY to point along the incline and perpendicular to it respectively, then the weight is minus mg cosine alpha EY plus sine alpha EX. The friction force is some value along the incline. It can be positive, it can be negative, not sure. We're gonna solve for it, and n is NEY. Okay, so if the friction is static, then the acceleration of the block is 0. The block is not moving with respect to the surface. So if I write F equals ma, basically A is 0, so F is equal to 0. So I'll get minus mg cosine alpha ey plus sine alpha ex plus ff ex plus n ey is equal to 0. And I can project along ff and along the normal force. I can project along ex and ey to get that minus mg sine alpha plus the friction force is equal to 0, and minus mg cosine alpha plus normal is equal to 0, meaning that the friction force is mg sine alpha and the normal force is mg cosine alpha. And so if the friction is static and the acceleration is 0, friction is this, the normal force is this, and these values, these forces should satisfy the static friction criterion. Which is that the magnitude of the friction force should be less than or equal to mu s, the magnitude of the normal force. M g sine alpha less than mu s, m g cosine alpha. M and g are positive constants, I can divide by them, and then I'll have that sine alpha should be less than mu s cosine alpha, or mu s should be greater than sine alpha over cosine alpha, which is tangent alpha. Okay, if this is not the case, then the block is sliding. The case, then the block is sliding down the incline. Okay, so if the block is sliding down the incline, friction is no longer kinetic, friction is static. So, friction is no longer static, it's kinetic. So if VREL is different than 0, friction is kinetic. Okay, kinetic friction is prescribed. Okay, so unlike static friction, which we need to solve for, kinetic friction we know it's minus mu k times the magnitude of the normal force, VREL over the magnitude of VREL. So the direction is the minus sign opposite to the relative velocity. So the friction force is prescribed and it's completely known. And then we can plug it in and solve for the motion. And solve for motion. Okay, so basically if I have a box sliding down an incline, the EX is this way, EY is this way. However, the box is going down the incline, V is x dot EX, and A is x double dot EX. If I draw the free body diagram of the box, the forces acting on it are the weight, the normal force, and the friction force. Weight is minus mg, cosine alpha EY plus sine alpha EX. The normal force is N EY, and the friction force, we can just use the prescription here to say what it is. So the friction force, it has it's minus mu k, the magnitude of the normal force, which we're gonna have to find, times VREL over VREL. Well, here the VREL is the velocity of the block minus the velocity of the surface underneath it, which is the incline, and that's 0. So VREL is just the velocity of the block, which is x dot EX, and the magnitude of VREL is the absolute value of x dot. So then VREL over the magnitude of VREL is x dot EX over the absolute value of x dot, which is just the sine of x dot EX. The sine of x dot is 1 if x dot is positive, and minus 1 if x dot is negative. We're not considering the case when x dot is 0, because that would be the case of static friction. Okay, so then our friction force is sine x dot EX, and we can write F equals ma from these forces to solve for the motion, to solve for the acceleration. So one thing I want to point out about this is that if the particle is going down the incline, particle going down the incline, x dot is less than 0. So this is the particle or the box going down the incline. Then the friction force is gonna be, well, sine x dot is gonna be minus 1, and the minus, the friction force is gonna point, the friction force is gonna point along EX like this. And if the particle is going up the incline, then the velocity is like this, and this friction force, well, x dot is positive, and the friction force is gonna point down. Okay, one thing I need to say is that this coefficient over here, mu k, this is called the coefficient of kinetic friction. In some books you might see it as mu d, coefficient of dynamic friction. So dynamic friction, that's the same as a static friction. So again, let me repeat that friction has two cases, static friction and kinetic friction. Static friction happens between two surfaces when the relative velocity between them is 0. In the case of static friction, the friction is an unknown that you need to solve for, but once you solve for it, you need to make sure that it satisfies the static friction criteria. If it doesn't, then friction is kinetic. Friction is kinetic, meaning that the bodies are sliding, moving with respect to each other. The relative velocity between them is non-zero, and then the friction then is prescribed according to this equation. So now it's known, but what's unknown is the acceleration of the box, which you can solve for from F equals ma by plugging this for the value of the friction force. We're gonna do some examples in another video.